Alright guys, I'm going to talk about 10-3 radical equations today, and just like what it's intended for, we are learning about radical signs, okay? And of course it's going to involve an equation, or in this case an equal sign will be involved as well. You will see an actual equation involving radical signs, and you're going to be learning how to solve for a particular variable. It could be a, it could be b, x, y, whatever it is that's going to be given to you. So let's talk about the primary goal here for this particular lessons. We want to be able to isolate the radical variable. What does that mean though? It means that when you're done solving, typically you want to have just the radical containing some kind of variable inside it on one side by itself. You don't want anything in the front of it. You don't want anything in the back. I'll show you an example in a minute to tell you what it really means by isolating the radical variable. Of course, just like always, you want to check for your solutions carefully. Make sure that everything works just right. Otherwise, whatever you got back might be what we call an extraneous solution, because when you plug it back in, it simply doesn't work. And last but not least, I want you to understand about the mutual enemies here. For example, when we're talking about opposite operations before, plus is a mortal enemy to minus, because that's the opposite operations, right? And when we solve equations, we want to perform the opposite operations, just like division is the opposite of multiplications, okay? And for this particular lessons, you'll be using this a lot, the square root sign and the square, because they are, like I said, natural enemies. When you take the square root of something, you want to undo the square root signs. All you have to do is just square it. For instance, if I say the square root of x and I want to get rid of the square root signs, all I have to do is square it, and naturally it will cancel the square root sign and the square out. And the reason for doing that is because, of course, if you actually expand this, the square root of x square means the square root of x times the square root of x. You learn the operations of radicals before. X times x is x squared inside, and as you can see, the square root of x squared means I want to look for a twins, right? We do have a twins of x, so therefore the answer is just x. So understand that the square root signs here is the mutual enemies of square. Okay, we're going to need to use that a lot for this particular lessons. So let's take a look at our first example here. Let's say I have the following. 3 times 4a, square root of 4a, minus 2 equals to 10. Now look back to our first primary goal. We want to have what? We want to have the radical variable completely isolated. Okay? So when we first identify here, notice here's the radical. So whatever inside is the radicand, and there's a variable in there. So basically, this is the part that we want to isolate from the rest of the equation. So we need to move the 3, we need to move the minus 2, and just like a regular equations, if this is the part that we want to keep, we naturally have to get rid of negative 2, right? Remember, the distance will be the first to go. So I'm going to add 2 over. That's going to give us 3 times square root of 4a equals to 12. And here, if I want to get rid of this 3, remember the opposite of multiply is divide, so I'm going to divide it by 3. So the square root of 4a is going to be 4. See? Now we achieve our primary goal. We have the radical all to itself, and of course the variables in it. And now, if we want to get rid of this, remember, we want to solve for a. We cannot solve for a until we get rid of this radical sign. That's the primary goal as well. How do we get rid of this radical sign? Just like what we learned about mutual enemies. All we have to do is take the square of it. If we take the square on one side, we have to take the square on the other side as well. And of course, the square root and square will cancel out. And you have 4a left on that side. 4 square over here is going to give you 16. And of course, if you divide by 4, a simply is going to get you 4. And you do it, if you check your work, just make sure it works. Plug in 4 back into here. You will have 4 times 4 minus 2 equals 10. See, that's going to work out fine. Square root of 16 is 4. So 3 times 4 minus 2. Indeed, it is 10. Works perfectly. So I want you to go ahead and try number 11 in your workbook on page 129. Okay, so try number 11. Move on to the next example here. Bit more complicated, but we still apply the same exact rule. I have a square root of 1 minus 2b equals to 1 plus b. Now, interestingly enough, this problem has variables on both sides. However, that's not what we care about at this point. Remember, we can't touch anything inside a radical sign until we completely get rid of it. So all they really refer back to, once again, is the boundary goal. Do I have my radical variable isolated? When we look at this right here, there's nothing in the front of the radical sign. There's nothing in the back of it. So technically, it is already isolated. You see it? I don't have any do anything extra. I don't care about combining like terms yet because I can't even touch the inside of this until I get rid of the radical signs. So once again, I'm just trying to remind you, all that you need to do is to isolate the radical. Is it all to itself on one side with the variable inside it? If the answer is yes, you go for the next step, meaning to cancel out the radical sign. How do I cancel that out? Easy. Square both sides. Okay, don't forget, you got to square both sides. And over here, very important, you don't just square one and then square b. You got to square both of them as a whole group. Now notice I'm putting the parentheses around it. And that hopefully reminds you to, if you don't remember, you can fold it or you can set up a box for it. So I'm just going to show you this again. Square of the radical, gone. So on the left-hand side, you just have 1 minus 2b. On the right-hand side, please do not just take 1 square plus b squared because that's not correct. What you want to do, if you don't remember how to FOIL, is to set it up using a box. 1 plus b, 1 plus b, right? This is twice, so you have to write it twice. And just multiply it out. Here's 1, here's b, here's b squared. Combine like terms. What you have now is 1 plus 2b plus b squared. So I'm just going to kind of distance it from the rest. So this is just my side work to get this result. Now you can start combining like terms because I managed to get rid of the radical sign. I'm just going to go ahead and move everything over to the right hand side. So I'm going to add the 2b over. That's going to give me 1 plus 4b plus b squared. I'm going to minus the 1 over as well. That's going to give you 0 equals to 4b plus b squared. At this stage, I'm solving for 0, right? I'm solving for b. So I can go ahead and factor out the b using GCF. I'll end up with b times the sum of 4 plus b. There's a GCF of b. And once again, I have two cases. I'm going to use my zero product property. So b is 0. That's one solution. And the other one is 4 plus b equals to 0. Solve for it. B is a negative 4. Now, like I said, don't assume that this is correct right away. You really want to test it out to make sure everything works just fine. So I'm going to do my check here on the side. I'm going to use 0. It's easiest to test, so I'm going to go ahead and plug it in. 1 minus 2 times 0. Will that equal to 1 plus 0? That is my original equation, so I'm plugging it back into my original equation. As you can see, 1 minus 0 is 1. Square root of 1 is 1. 1 plus 0 over here is also 1, so that's a good answer. Move on to negative 4. Let's try that. I'm going to have 1 minus 2 times negative 4 equals to 1 plus negative 4. Okay. Inside here, I'm going to have 1. This negative 2 times negative 4 is 8, so 1 plus 8 is 9. Over here is 1 plus negative 4 is negative 3. And as you know, the square root of 9 is positive 3, and this is a negative 3. Those are not the same. So because of that, I can conclude that this is my extraneous solution. Okay, so that's going to be my double spell. Extraneous solution, and basically your final solution is going to be 0. My extraneous is going to be negative 4. Okay, so here's the last try this problem. I want you to go try, once again, number 11, but on the other page, page 130. So go ahead and try this out, and we're going to discuss this when you come back, okay? All right.